Okay, this one is subtracting polynomials. So, in the last lesson we talked about the adding of polynomials, and I said, oh, don't be distracted by the parentheses or the grouping because it doesn't really change anything. Well, it is important in this lesson. So with the subtracting of polynomials, the game changer in this one is this subtraction symbol right here. The previous lesson, it was an addition symbol in between. I told you the groupings, you could switch things around, didn't really matter, didn't change the sum. So here's what's the deal with the subtraction symbol. It's kind of like a -1 in front of the second grouping. So you can think of it in two different ways. You can think of it as distributive property. So I'm multiplying by every term on the inside of the second grouping by -1. And as you know, when you multiply any term by -1, he's basically turning to his opposite. So this 8a, positive 8a, would become -8a. And this -6a squared would become positive 6a squared. And this -4 would become positive 4. Or you can just think of it as everyone in the second grouping, they just flip to their opposites. But here's the thing, the first grouping, he's not affected at all. He just basically stays exactly the same as he is. The only reason the second grouping is affected is because it has a subtraction sign in front of the group. So you can either rewrite the first grouping. As you know, I like to rewrite things. So now I'm looking at one string of terms. And now we're doing exactly what we did with the adding of polynomials. We're identifying our like terms. So we have 4a squared is friends with positive 6a squared. We have our -5a, who's friends with -8a. And then we have our constants of 2 and 4 that are like terms. So now all we're going to do is put them together. So 4a squared and 6a squared when put together make 10a squared. We have -5a and -8a when put together. That gives us -13a. And lastly, we have the constants 2 and 4 when put together make 6. And that's it.